In this video, we'll use n8n and Home Assistant to build an AI health monitor from door sensor. By placing it on a toilet lid, we'll get a weekly count of toilet usage, including data on nocturia, and have an AI analyze it for any significant changes that could indicate a health issue. Let's kick things off with the very first node in our workflow, the schedule trigger. For its configuration, we've set it to run once a week every Monday at 9 a.m. sharp. At that time, our trigger fires and the weekly analysis begins as the workflow immediately splits into two parallel data collection paths. On the top path, we have an HTTP request node I've renamed Toilet History. We're using it to query the Home Assistant History API. The URL is dynamically constructed to get data from the last 7 days, and in the query parameters, we filter for the specific entity ID of our toilet lid's Tuya door sensor. For authentication, we're using HTTP header auth with our Home Assistant long-lived access token. This pulls in a complete time-stamped list of every state change from the past 7 days. But this data is messy. It includes on, off, and the timestamps aren't localized, so the signal flows to a code in JavaScript node. The code inside does two key things. First, it filters the raw data to keep only the records where the state is on. Then, it uses n8n's date-time object to convert the timestamp of each event to our local time zone. This transforms a noisy feed into a clean, accurate list of every toilet use this week. Meanwhile, on the bottom path, we need to get our comparison data. This starts with a data table node I've renamed Get Last Week's Summary. Now, let's look at its configuration. In Data Table, we're choosing From List and then selecting the Weekly Toilet Summary table that we've already created in n8n's Data Table section. This table has 3 columns: week start date, total count, and nocturia count to store our weekly summaries. And finally, we enabled the Return All option because we want to pull the entire history of our weekly summaries. For our comparison, however, we only need the most recent summary. This brings us to the next JavaScript node. The code inside here is very efficient. It simply sorts all the historical summaries by their start date in descending order, and then returns only the first item, which is guaranteed to be the report from last week. At this point, we have 2 clean sets of data: this week's raw events from the top branch and last week's single summary from the bottom. We need to bring them together. This is the job of the merge node. Its mode is set to append, which will output items of each input one after the other. It takes all of this week's records and adds last week's summary to the end of the list. We set the number of inputs to 2 since we're merging our 2 data streams. But now we have a stream of separate items. Before sending this to the AI, we need to do one final packaging step with an aggregate node. In its configuration, we just select all item data. That's it. This bundles everything into a single consolidated package, ready for our AI. The moment we've been waiting for. This package now goes to the undisputed brain of our operation, the AI agent. This is our AI-powered health data analyst. In its prompt, we've given our Google Gemini 2.5 Pro model a complete analytical methodology. Separate the data, calculate this week's total usage and nocturia counts, compare them against last week's summary, and then, based on our predefined thresholds, like a 30% change, determine if the trend is significant. To ensure the AI's complex response is always in the perfect format, we then attach a structured output parser. Inside this node, we provide a JSON example of the exact output we expect, and to make it even more reliable, we enable the Auto Fix feature and connect a second Google Gemini model. This creates a powerful validation loop. By doing this, we're not just asking it to do math, we're asking it to be a data scientist. With the AI's in-depth analysis complete, the workflow now splits into its final actions. The first fork in the road is this crucial if node. Its configuration is a simple rule. Is the is significant change flag from our AI's output equal to the number 1? If the answer is yes, the workflow proceeds down the true path to our ticketing system. If no, the false path is a dead end. This node is the critical gatekeeper that ensures we are only alerted when the data truly warrants our attention. On that true path, we have a Google Tasks node named Create a Task. This is our health alert ticket. We choose our task list, set the title to Health Anomaly, and in the additional fields, we use an expression to pull the entire human-readable report from our AI into the notes. We also set a due date a few days in the future to ensure the alert is reviewed. By automatically creating this ticket, the automation has escalated a potential issue in a structured, actionable way. Finally, regardless if there's an alert or not, a parallel path is always executed. This is the Insert Row node, our history keeper. Its operation is insert row into our weekly toilet summary table. In the columns, we map the new data that our AI prepared for us, pulling the week start date, total count, and nocturia count from the record for data table object the AI generated. This is the final step in our data cycle, ensuring our systems analysis becomes more robust with each passing week. So there you have it. This weekly workflow automatically analyzes toilet usage data with an AI, compares it to the previous week, and creates a health alert in Google Tasks if it detects a significant trend. By the way, I've bundled everything from this build into a guide for you. You can find that link waiting in the description. I'm always looking for new ideas, so share what you'd like to build together in the comments. Every like and subscribe truly helps the channel expand. Thanks for watching.